Lesson 11-7, Proportions and Similar Figures. By the end of today's lesson, you will be able to write proportions involving corresponding sides of similar figures, as well as use proportions to find missing side lengths of similar geometric figures. Make sure you have your pencils and papers ready so you can work right along with me. Go ahead and copy these down in your notes. The first one is the lengths of the corresponding sides of similar figures are in proportion. And then remember that similar figures have the same shape and they're congruent. Here we have similar figures. They are the same shape. You can see that they're both rectangles. And their corresponding angles are congruent. They have the same angles in the same spots. So we can say that A, B, C, D, the shape ABCD, is similar or congruent to the shape WXYZ. So since these are congruent and similar figures, we can compare the sides and create the proportions that go along with them. So in this first shape, if we have side AB, right here along the bottom, side AB, that one would be compared to WX. So AB to WX is equal to, so we've compared those on the bottom. Now we're going to compare them to the ones on the right side. BC over XY, which would be the same as comparing CD along the top to the same one along the top on the other side, YZ, which is the same as AD, which is along the left-hand side, over WZ. So there it is if you just look at the shapes and comparing the shapes. Now we're going to take a look at it using fractions. So we're going to plug those values in here. So AB, that would be 6 over 9. WX, right here we can see, is 9. WX is 9. So then the BC right here to XY. So we compare this BC, which is 2, to XY, which is 3. So that would equal 2/3, which is equal to, then we've got along the top CD, which is 6, to YZ, which is 9, which is equal to AD, which is 2, over WZ, which is 3. So now we can write those as the other proportions where we're dividing 6, let me change colors. We have 6 divided by 3. We're working right here with these 6 and 3, and then, or we're going to reduce the 6/9, sorry, we're reducing 6/9, so we can divide those both by 3. 6 and 9 are both divisible by 3, and when we reduce that down, it equals 2/3. So we can see this 2/3, that is equal. We've already reduced that, so these all reduce down to equaling 2/3. In these examples, we're going to be comparing congruent or similar triangles. So we have triangle EFG right here, and here we have triangle PQR. So if we want to know what the length of GF would be, we can take a look here and compare those sides. So here's GF right here. So we're going to be comparing that to its congruent side, which would be right here, RQ. So we write that as a fraction, and we would compare EG to PR, because we want that whole ratio, is equal to GF, which is what we're trying to find out, over RQ. So EG, that equals 9. PR, if we look up at the triangles, that equals 18, which is equal to, we don't know what GF is, I'm going to just use an M for that. And then we have RQ, which equals 24. So now we have that proportion. Now we're going to use the cross products rule. So we're going to multiply 9 times 24. 9 times 24 equals 18 times M. So then we rewrite that. So 9 times 24 is 216 equals 18M. Okay, now we need to divide both sides by 18 to get the M by itself. 216 divided by 18 equals 12. So 12 equals M. So the length of GF would be 12 centimeters. So I want you to try this one. We have these two triangles. We have triangle ABC, comparing that to triangle RST. So if you will need to write the proportion and write the length of the corresponding sides in a proportion for each pair of the smaller or similar figures. So the proportion, I want you to write for each side, comparing all of the sides. So go ahead and pause the video and then come back and check your work against mine. So we're going to start comparing. I'm going to start with AB, which would be 12, comparing that to the corresponding side RS, which would be 8. So 12 over 8 would be equal to, then I'll just go along the bottom, or I'll go AC, which would be 15, over, then I'm doing RT, which would be 10. You may not have them in this specific order, but as long as each of the fractions is the same, it's fine. Then the last one would be 9, 6. So as long as you have these three fractions, it doesn't matter what order they're in, that's correct. So what if I were to reduce each of these, what would they reduce down to? So I'm going to just take a look here at the 9, 6 and know that I can divide both of those by 3. 9, 6 divided by 3, that would equal 3 halves. Now if I reduce this one down, the 15 tenths, I know 5 goes into both of those. 5 goes into 15 3 times, 5 goes into 10 2 times. Now this one of the 12 eighths, that 4 goes into both of those, so that would be 3 halves. So these all reduce down to 3 over 2, so that would be my proportion for this one. Go ahead and rewatch any part of today's video before heading off to do today's assignment.